Hi ladies, Mrs. Lovitz here again. This is lesson 2.6 for geometry, and it's about special angles, and we're speaking specifically about parallel lines. And in this lesson, we're going to look at the relationships of angles related to parallel lines that are formed by a transversal. And this is a key term that we have this lesson, a transversal. So some key terms that we have, and you'll see those on your note sheet. The first one is transversal, and you can see at the diagram to your right that it's referring to that line that's cutting to those two parallel lines. So a transversal is a line that intersects two or more other lines. And on your figure, on your note sheet, so you see the transversal, that's the line that cuts across those two parallel lines. And then the corresponding angles are the angles that correspond with each set of lines in the transversal. So let's look at the figure. So here's your transversal. This line here, that's your transversal. It's cutting, and these lines are not parallel, but they are, because we're talking about parallel lines here. So those two lines are parallel. Corresponding angles is this angle on the top line cut by the transversal, and this angle on the bottom line that's cut by the transversal. So let's look for other pairs of corresponding angles. So these are on the same side of the transversal and on the same side of the line, the parallel line. So 1 is on the left side of the transversal, 5 is on the left side of the transversal, and they are both above their corresponding lines. So some other corresponding angles, angle 2 is on the right side of the transversal, and it's on the top of the line, and angle 6 is on the right side of the transversal, and it's on top of the line. Angle 8 and angle 4, they're both on the right side of the transversal and on the bottom of their corresponding lines. And angle 3 and angle 7 are corresponding angles. They're on the same side of the transversal and the same side of the line. So those are corresponding angles. Alternate interior angles. Alternate interior angles, one of them is angle 3 and angle 6. So angle 3 and angle 6. They are both interior angles, so they both touch they're at opposite sides of the transversal, but on the same, within the same, in between the parallel lines. So in between the lines on opposite sides of the transversal. So another set of alternate interior angles, 5 and 4, they are both in between the parallel lines, but on opposite sides of the transversal. And alternate exterior angles. Now we're looking at angles that are on the outside of the parallel lines. So they're both outside of the two lines, and they're on opposite sides of the transversal. So 7 is on the left side, 2 is on the right side of the transversal. So another set of alternate exterior angles would be 8 and 1. So they're on opposite sides of the transversal, and they are both outside of the two parallel lines. So going back to the first slide, jot down those definitions for transversal, corresponding angles, alternate interior angles, and alternate exterior angles. So here in the definitions, you should have transversal is a line intersecting two or more lines. Corresponding angles are angles on the same side of the transversal and the same side of the pair of lines. Alternate interior angles are angles on opposite sides of the transversal, and they are in between the pair of lines. And alternate exterior angles, angles on opposite side of the transversal and outside the pair of lines. So in this lesson, we have a few conjectures, and remember, a conjecture is if A, then B. So it's an if-then statement relating to two separate pieces. So this first one, we have the corresponding angles conjecture, or we call it the CA conjecture. So if two lines, two parallel lines, so here are our two parallel lines, and they're cut by our transversal. Here is our transversal. Then what is true about the corresponding angles? Angle 2 and angle 6. Those two angles are congruent. The second theorem is alternate interior angles conjecture, or AIA conjecture. And so again, we have this line is parallel to this line, marked by our parallel markings. If it says two lines are parallel, they're cut by the same transversal, then we're looking at our alternate interior angles. So here's our transversal. We're looking at the opposite sides of the transversal, but in between the parallel lines. Those two angles are congruent. And the alternate exterior angles, or AEA conjecture, if two parallel lines are cut by a transversal, then alternate exterior angles are also congruent. So it's true with more of the lines than are identified on here. So the first one, two parallel lines are cut by a transversal, corresponding angles. We have angle 2 and 6, but also it's true about these two angles. They're corresponding. Or about these two angles that are corresponding. Or about these two angles that are corresponding. So it's true about all corresponding angles related to specifically parallel lines cut by a transversal. For the alternate interior angles conjecture, we're looking at angle 3 and angle 6, but it's true about all alternate interior angles. And then same with the alternate exterior angles conjecture. We're talking about angles 1 and 8, but we also have these two angles as alternate exterior angles. So if two parallel lines, two parallel lines are cut by a transversal, then corresponding angles, alternate interior angles, and alternate exterior angles are congruent. So if we combine those three conjectures, the corresponding angles conjecture, alternate interior angles conjecture, and our alternate exterior angles conjecture, we get the parallel lines conjecture. So if two parallel lines, are cut by a transversal, then corresponding angles are congruent. Alternate interior angles are congruent, and alternate exterior angles are congruent. So that's our parallel lines conjecture. That's saying that all three of those are true. So what happens if we start with lines that are not parallel? So here, this line is not parallel to this line. Then we still have corresponding angles. These are all our corresponding angles. Same side of the transversal and same side of the line. However, they are not congruent. So if we don't have that key piece, the two parallel lines cut by a transversal, then the corresponding angles are not congruent. And then we can say the same thing about the alternate interior angles. So here's an alternate interior angle, not congruent. Here's another, oops, sorry, that's actually, here's alternate interior angles, not congruent. And here's our other set of alternate interior angles, not congruent. So if you don't have parallel lines, then your corresponding angles are not congruent, your alternate interior angles are not congruent. And let's look at our alternate exterior angles. Those are also not congruent. Our alternate exterior angles are not congruent. So therefore, our parallel lines conjecture, if we don't have that parallel lines, then none of those pieces are true. So now let's look at the converse statements, the converse of our conjecture. So our conjecture again says if A then B. The converse would say if B then A. So the converse of the corresponding angles conjecture, the conjecture says that if two parallel lines are cut by a transversal, then corresponding angles are congruent. So our converse of our corresponding angles conjecture would say if corresponding angles if corresponding angles are congruent, then the transversal cuts two parallel lines. Now the converse of the alternate interior angles conjecture is, well, first the conjecture is if two parallel lines are cut by a transversal, then the alternate interior angles are congruent. So if the alternate interior angles are congruent, then the transversal cuts two parallel lines. And then the last one, the converse of the alternate exterior angles conjecture. First, the conjecture states that if two parallel lines are cut by a transversal, then alternate exterior angles are congruent. So the converse of that, switching the B and the A part of the statement, is if alternate exterior angles are congruent, then the transversal cuts the two parallel lines. So remember this symbol here means parallel. So then combining all of those converses together, if two lines are cut by a transversal to form pairs of congruent corresponding angles, then congruent alternate interior angles or congruent alternate exterior angles, then the lines are parallel. So in this example, the parallel lines conjecture and the converse of the parallel lines conjecture is going to hold true. We don't get into deductive reasoning in this class, but just so that you can see kind of the way we know that how we get to our final conclusion. So in this diagram, L and M, these are parallel lines, and they're intersected by transversal K. If the corresponding angles conjecture is true, so assuming that corresponding angles here are congruent, then we can say angle 1 is congruent to angle 2. Now, next, if we're assuming the vertical angles conjecture is true for lesson 2.5, then we can assume that these two angles are congruent. Angle 1 and angle 3 are congruent. Because 2 and 3 are both congruent to angle 1. So 2 is congruent to angle 1, and 3 is congruent to angle 1. Then, using the property of transitivity, so if A equals B and B equals C, then A equals C, we can say that angle 2 is congruent to angle 3. And angle 2 and angle 3 are alternate interior angles. And they are congruent. So that's the process you should be thinking of. In this class, you don't have to write it all out, but you should still be thinking through that process. So on your own, try the extra example and then also try the closing question. Please pause the video while you work and unpause for the solution. So in this extra example, the first thing I know is I see X here, and I see that these two lines are parallel. So if the alternate interior angles conjecture is true, which we are in this lesson, we just decided that yes, it is true. Alternate interior angles are congruent. So that means this angle here is also X. Then I can use the linear pair conjecture. And the linear pair conjecture says that if two angles form a linear pair, then they sum to 180 degrees. So here's my linear pair. This angle and this angle form a linear pair. They're on this line. So I can say x plus 2x plus 45 equals 180, and then I can use algebra to solve for x. So I get 3x plus 45 equals 180. Subtract 45 from both sides. And then I get 3x equals 135. We need to isolate x, so I'm going to divide both sides by 3, and I get x equals 45 degrees. Then please answer the closing question. Please pause the video while you work, and then you can unpause for the solution. It says to find the relationship between angle 1 and angle 2 using transformations. So what do you know about this line and this line? And how can you relate those two angles? And then, using a transformation, how would you describe the relationship? We know that these two lines are parallel, and then this line we would call our transversal. And so if two parallel lines are cut by a transversal, angle 1 and angle 2 are corresponding angles and they're congruent. So if these two angles are congruent, then the transformation would be a translation. And angle 1 can be translated down 2 units and over 2 units. So we can describe the translation from angle 1 to angle 2 using the vector -2, -2.
Please jot down any questions you have in this lesson. We'll do some extra practice problems when I see you next time in class, and we'll go over any questions you have. Thanks, ladies.